Okay, in this video, I'm going to talk about dative covalent bonds, which is something that you haven't done at GCSE. So this is something which is new. Now, in a dative covalent bond, two atoms share a pair of electrons. So nothing new there, you may think. But the difference here is that what makes it different to a normal covalent bond is that both the electrons come from the same atom. So one of the atoms doesn't actually provide any electrons for the bond at all. Okay, so let's think about the most a species you will come across before. You will have come across, right, NH4 plus, which is called the ammonium ion, and that has got a dative bond in it. So don't forget that ammonia is NH3. That's ammonia, which is a gas which is very soluble in water. Okay, so let's draw a dot cross diagram for ammonia first of all. So ammonia has, right, we've drawn this lots of times before. The nitrogen, right, so a dot and a cross where the overlap is, dot and a cross. Nitrogen is in group 5. We've only drawn 3 crosses, so we need to have a lone pair up here. Okay, so these are all hydrogen atoms here. So what can happen is this can grab hold of an H plus ion. Okay, so an H plus ion is a hydrogen atom that has lost its electron. So there'll be a hydrogen atom with its electron, and H plus is when it's got no electrons at all. Okay, so what happens is this can form a dative bond. Okay, so this hydrogen, this H plus, can come here. So this bond would be the dative bond, and it's got 2 electrons, but they're both coming from the nitrogen. And of course, that would mean this hydrogen came along without any of its own electrons. So but it did have a positively charged proton in the nucleus. So that, of course, is going to be a positively charged ion now. It's important to realize just a couple of things here. First of all, the positive charge doesn't just sit on this red hydrogen here. Yeah, I know that's the one that didn't come with an electron, but it's just the whole structure has got 1 electron missing. It's got 1 more proton than it's got electrons, and that's why the whole thing is positively charged. It's kind of shared everywhere. Also, another thing is, if you think of these 3 bonds here, if you looked at them, you won't be able to tell the difference between any. They're all this dative one isn't special, right? Because once it's formed, you don't really know where the electrons have come from, and so they're all the same. Usually, the way of drawing a dative bond is you draw, well, a normal covalent bond you draw as sticks, don't you? A single bond with a stick, a double bond you draw as 2. And to show a dative bond, you draw a stick, but you put an arrow on it, and you put an arrow in the direction of the atom that is providing the electrons, the one that isn't providing any electrons. So that's how you would draw the ammonium ion in that way. Okay. And if you wanted to imagine the shape of that, well, what would it look like? You'd have your nitrogen there, and you'd have 4. Okay, and this one here, this one, which I'll colour in red, which was nominally the dative bond, it wouldn't look any different from the other ones. It'd be the same. Okay, and this would be NH4 plus, would be almost exactly the same shape as methane, which we looked at a couple of lessons ago. Okay, so that is a dative bond, right? Let's think of another really important dative bond, another species with a dative bond, and that is right. if ever it's the H3O plus ion. you won't have heard of that before, and if you're in a chemical equations, you quite often see written down the H plus ion. Okay, but the H plus ion really doesn't exist by itself. It's really H3O plus. You can't have an H plus ion just floating around by itself, because if you think about it, that wouldn't have any electrons at all. It would just be a nucleus. Okay, and that would be, and you know how big the nucleus compared to the atom, it's like 1/10,000th of the diameter, isn't it? So the positive charge on this would be incredibly intense, the charge density, because it'd be plus on a very, very small thing, and that's not going to happen. So people write H plus in equations all the time, but it's understood that that doesn't really exist. It's H3O plus, and we'll see basically this H plus piggybacks onto a molecule of H2O. Okay, so let's draw our H2O molecule, dot cross diagram. And then we need two lone pairs because oxygen's in group 6. So we've got a lone pair there and a lone pair there. And to form the H3O plus ion, what happens is a proton comes along here. And it forms a dative bond. Okay, then that proton came without any electrons of its own, so there's now one more positive charge on this than there is negative, so it's got a positive charge. So if you think about it, it's like the H plus piggybacks onto a water molecule, and then the positive charge is shared over the whole species, the whole H3O plus. It's not just sitting on a tiny proton. Let's have a little quick think about the shape of that. Well, the shape of that is going to be very similar to ammonia, because we're going to have, here's the oxygen, we're going to have 3 bonding orbitals there to the hydrogens. Again, one of them normally is going to be, you can't tell the difference between that one looking at it. And then here, we're going to have the lone pair, which is slightly different shape. So very similar shape to the NH3 molecule. This is the H3O plus ion. I think now we'll have a little look about how the ammonium ion actually forms with water. Okay, so if you get ammonia gas, ammonia is very soluble. It's a gas, very soluble in water, and it reacts with water. It's an equilibrium reaction. Some of the NH3s grab hold of a proton, they get a proton off the water, and they form NH4 plus, and what is left behind is OH minus. Okay, so so this is, as I say, this is an equilibrium reaction. It's not every NH3 that does that. Most of it, the equilibrium is over to the left. Most of it stays simply as NH3, but a small proportion of them remove H plus ions from water to form NH4 plus and OH minus. And of course, this is going to make the solution alkaline, isn't it? Because you've got hydroxide ions there. So if I just draw a dot cross diagram, so we've got ammonia. I'll draw ammonia in black. And it's got its lone pair there. And I'll draw water in red. Okay, I'm going to draw an H. Right, so you've got that there. And we've got 2 lone pairs on water, on the oxygen. Okay, so there's the ammonia and there is the water. And what happens in this reaction is, well, this hydrogen, one of the hydrogens is transferred from the water molecule to the ammonia molecule. So I draw it now. This what it's going to be is you're going to have and here is our right now. These are all normal bonds, yeah. But this one here, both of those electrons came from the nitrogen. They weren't provided by the hydrogen at all. So that means this species has got a positive charge on it. It's the NH4+ ion. And let's draw what's left over from the water. We draw that in red. So we're going to have an oxygen with just one hydrogen attached to it now. So oxygen has got 6 of its own electrons. I've only drawn one of them so far. So I need to draw 5 more. So we have 2 lone pairs here. And then we have got this lone pair. And that one, the cross came from the hydrogen atom, which is now gone and has left it behind. So you have, this is now a hydroxide ion. It's negatively charged. Okay, in the next video, I'm going to give some more examples of dative covalent bonds. Okay.